Hello students, now we are going to discuss about components of LT switchgear. First of all, we need to know what is a switchgear, right? The apparatus used for switching, controlling and protecting the electrical circuits and equipment is known as switchgear. Okay, so the apparatus which is used for switching, controlling and protection of electrical circuits is called switchgear here. Okay, generally switchgear is a term which consists of wide range of products like circuit breakers, switches, fuses, off-load isolators, HRC fuses, contactors, earth leakage circuit breakers, etc., etc. Okay, so all these apparatus protecting, controlling and switching our electrical circuits and equipments is called switchgear. Okay, so switchgear is a set of equipment used for mainly for protection purpose of our electrical equipment. Okay, so let us see one by one. So we need to understand the classification of switchgear based on the voltage level. Switchgear is classified into three types. First one is low voltage LV switchgear up to 1000 volts. Okay, if the operating voltage is below 1000 volts, the switchgear used for the equipment is called low voltage switchgear. If the voltage is between 3000 to 11 kV, 3000 to 33000, then the switchgear used is medium voltage, and if the voltage rating is more than 33 kV, the apparatus that are used for protection of equipment is called high voltage switchgear. Okay, so these are the types of switchgear here. Classification is low voltage, medium voltage and high voltage switchgear. Okay, now let us see the components of LT switchgear. Okay, so LT switchgear includes low voltage circuit breakers, switches, off-load electrical isolators, HRC fuses and ELCBs, MCBs and MCCBs. All the accessories required to protect the LT switchgear will be included in the LT switchgear. Okay, so the most common use of LV switchgear is LV distribution board. Okay, now let us see the first equipment used for protection of electrical circuits is fuse here. So most of you know what is a fuse look like. Okay, and let us see what is the definition for a fuse. Fuse is perhaps the simplest and cheapest device used for interrupting an electrical circuit under short circuit or excessive overload or current magnitude. So this is very important application. Okay, so fuse is the primary protecting device in any electrical circuits. So we obviously come across this fuse in our daily life. Okay, every domestic supply will be passed to the load through this fuse only. Okay, so this fuse will break the circuit whenever there is a short circuit or whenever there is a excessive overload or whenever there is a high current magnitude. Okay, the action of a fuse is based upon the heating effect. That means the fuse will melt whenever there is a overload or short circuit. So whenever there is a short circuit current flowing through the fuse, that fuse will generate some heat. That heat will melt the conductor which is connecting the two terminals of the fuse, and that will break the fuse. Okay, so by breaking the circuit, we are going to open circuit this whole equipment so that the current will be zero, by which we are going to protect the circuit. Okay, so the fuses will be having inverse time current characteristics. Okay, so I am going to show them inverse time current characteristics. That means if the current is high, the time for fuse to blow will be less. Okay, I hope you understand. If the more is the current, the time for fuse to break will be less. So that is what inverse time current characteristics. Here you can see. So this is on x-axis, it is time, and on y-axis that is current through the fuse here. So if the more is the current flowing through the fuse, the time taken for this fuse to break will be very less. You can see here. Okay, so as the current through the fuse is small, the time for breaking the circuit is increasing. Okay, the part which actually melts and opens the circuit is known as the fuse element. Okay, so you mostly know that. Okay, so fuse will be like this, and it will be having two bolts here. So there is a copper conductor which is connecting two lines here. So this one here, this is copper conductor. Okay, which is having only one string, one strand. So whenever there is a overcurrent flow, this fuse will be melt. Okay, now that is what fuse element. Okay, fuse element is a copper wire here. So let us see the advantage and disadvantage of fuses here. Okay, so what are the advantages of fuse? So we know that fuse is a cheapest material protection device, and it needs no maintenance until unless it blows. Its operation is inherently completely automatic, unlike a circuit breaker which requires an elaborate equipment for automatic action. Okay, so it is almost automatic, not like MCB, but it is somehow automatic. So it interrupts the short circuit currents without noise, flame or gas. Okay, so without any of these side effects, the fuse will open circuit the circuit whenever there is a short circuit current flow. Okay, now let us see the disadvantage of fuse. There will be a time for which the circuit to break. That means the fuse will take some time, okay, to rewire it and replace it. Okay, so we have to reconnect a wire between two terminals of the fuse and we have to insert it back. So that is one disadvantage of fuse. We have to take some time to wire it and we have to replace it. Okay, so if there is a heavy short circuits, so if let us say there are series connected fuses, so the discrimination between fuses in series cannot be obtained unless there is a considerable difference in the relative size of the fuse concerned. That means, so let us assume, so there are, so this is a symbol for fuse here actually, so this is symbol, so these are the fuses here. So let us assume these are three fuses here. Okay, so let us say all these are connected in series. Okay, if I consider I is the current, okay, so our fuse rating will be different based on the size of the conductor or fuse element. Okay, so here what he is saying is, on heavy short circuits, discrimination between fuses in series cannot be obtained unless there is a considerable differences in the relative sizes. That means, so let us say, so the thickness T1, thickness of this wire here, and here this is T2 and here this is T3. So let us assume T1 is greater than T2 is greater than T3. So whenever there is a high current flow, so the first fuse that will be blow is T3, because the wire has small size and it will blow out first. Okay, so based on the sizes of the fuse element, we are going to discriminate the fuses, okay, whenever there is a high short circuit. Okay, until unless there is short circuit, we cannot discriminate between fuses here which are connected in series. Okay, the current time characteristics of a fuse cannot always be correlated with that of